Good morning. My name is Pierre Raymond. I'm with Terra Erosion Control. I'm a soil and water bioengineering specialist, and today I will talk to you about the Riverdale Phase 2 downstream case study in which I collaborated with Cloncrip and Berger office in Calgary and the water resources from the city of Calgary, Abel Leon. I will discuss the river site, the background, site consideration, objective, remedial option considered, the design, implementation, maintenance, monitoring, and the lesson learned. There was an initial site visit on October 15 in 2015. The site is in established neighborhood parks with large mature trees and highly used by residents. It had a 70 years old wooden retaining wall treated with creosote along with contaminated soil present on site. The retaining wall itself had an average height of 1.5 meters and a length of 170 meters. It was supported by steel tie back cable and anchor cable. And there were discussion about cutting back the slope to 2:1, which would have involved removing existing mature tree and section along the riverbank. Other site consideration were that it is or was a steep vegetated embankment. It has a limited footprint for construction, and there was some discussion about the implication of future scour on how this would impact the design, as well as minimizing as much as possible the removal of vegetation on slope above the wall. And also discussed was the assessment of tree at the end of their life and or the one that were in poor condition to be removed. And it was mentioned by City Park that the dead tree were providing habitat for woodpecker that should be considered. Other site consideration were the access to large equipment within the city park adjacent to the river that may require a construction of a riprap access ramp into the river, the timing of implementation and river lowest flow level, the timing of construction with fish window, and the potential use of specialized equipment such as a spider hole to reduce the impact on the existing mature trees, and the importance of a maintenance program. The main objective of the project was to remove the old wooden retaining wall treated with creosote and contaminated soil and dispose of it off-site. A development of a riverbank protection incorporating soil and water bioengineering, a zero net increase in water level due to the encroachment by any future proposed design. And if there was to be encroachment, the potential of excavating gravel in the left bank gravel bar, zero net impact on fish habitat below the 1 to 2 year water level, of course, conservation of the existing vegetation, and to limit the footprint in the park and river and maintaining the existing pathway. Remedial options considered were art approaches such as steel sheet pile wall, or timber crib spurs using large boulder along the toe, such as the project shown on the slide here as Discovery Ridge on the Elbow River, or using large quarry block as toe protection, and as well as large tree anchor into the slope. Other options considered were natural-based solution, such as soil and water bioengineering, including vegetated timber crib wall with riprap at the base, brush mattress with toe of riprap, vegetated grown or spurs, also biodegradable erosion control matting and potted plant and native seed mix. And finally, the live grading, or also called slope grid, which was selected in an attempt to conserve and protect more the existing tree on site. I will now talk about the design, the live grading, which is a structure selected. The advantages are minimal excavation into the slope, minimal encroachment in the river, minimal damage to existing tree root system and their stability. It has benefit due to large woody debris on soil, minimal footprint, flexibility of the implementation within the site context. Also, it's a versatile type of structure that could be applied to slope failure or riverbank. It can be built on very steep slope gradient up to 55 degrees and can be used as a transitional structure. Example of live grading approaches, there are single vertical timber type. They're double type parallel to each other for deeper failure, and also double that are reaching to each other in a point shape to match the failure. Here is example of a double type of using logs and large grid on a project in near a highway in Austria. They came with a full landscape design plan to establish native species. And then this is the site after 25 years. Other example, closer to home, I guess this is the Memorial off-ramp in Calgary, using square timber. In this case, it's easier to build, but it's not as long lasting. The research has shown that processed timber versus raw log degrades faster. It's stabilized and vegetate very steep slope, as you can see here. And it's a good option where other techniques are not very viable. Works very well as a transition between built structure and existing slope or on itself. Here you can see the example is a vegetated timber crib wall, and we use the live grading to get back to reach the steep slope. So in some instance, we're rebuilding the slope as we're filling in material and void the space in order to go and connect with the existing slope. And then this is later in the winter. You can see downstream how it's meeting the steep riverbank gradient and upstream. And then the photo of 2 years of growth after the implementation. Another example of live grading approach combined with toe protection to include existing mature tree and shrubs on site. A timber grid is designed to include the existing vegetation. Suitable species that have advantageous root growth, such as species used in edge brush layers, are used. It is a superficial structure which is not intrusive and therefore reduces the damage to the existing root system. The grids that are created around the existing vegetation, it's filled in with river gravel and fine, and the stem will eventually grow roots along its buried part. This is an example of a project going on with the Urban System Office in the Kamloops region along the North Thompson River. Other component of the design was that we use rounded cedar logs that were salvage power pole with, of course, the creosote removed. This is a really good source of material. A toe of riprap, class 1M riprap, a double core geotextile, a wire mesh under the cuttings, as explained earlier, to bind the root mass with the slope. That will deteriorate over time. Brush layers, planting in between the rows of brush layers with native plants. And also important to mention that the live cuttings and planting were selected and located based on moisture and shade tolerance property. And we use a soil amendment that was incorporated into the planting of brush layers and rooted stock. and manual seeding of native seed mix at 40 kilogram a hectare applied under the core matting during the installation. So here's a plan view of the drawings and design. So basically what you can see is that there's the rock toe and the log placed first vertically and then horizontally, creating some planting cell. And at the toe, we the bottom we use 20 stem per linear meter of brush layers and 10 stem per linear meter for the remaining rows. It was also planted in between through the core matting and seeded under the matting. Here's a chart or a table of the botanical component. So you can see here the first row, second row to fifth row, and the estimate number of planting opening per row. Those are the planting cell I was talking about earlier. And the estimate linear meter per cell. Basically, the design was made to be 1.5 meter center to the log, which gives you a 1.2 meter linear meter within the cell to be planted. So this is the total linear meter per row, considering the opening size. And then there's your species, and then the stem per linear meter, 20 at the beginning, 10 on the subsequent second one. On the third row, we combine willow and poplar, and then no brush layer on the fifth row. And then in below here, you can see the rooted stock of native trees and shrub, and the selection basically going from more moisture tolerant and shade tolerant to less so as we're going up. And the container size. So first row was strictly red osier dogwood, and then it was a combination of golden currant and dogwood on the second row. Third row, we had Saskatoon berry and water birch. And then on the fourth row, we had again Saskatoon berry and choke cherries. And then on the fifth row, we had the roses. One of the benefit of using different species like that is also you could have different fruit-bearing shrubs and trees, which will further attract birds and increase your biodiversity on site. Project was implemented in the fall of 2016 and spring of 2017. The safety of the proposed work required a proper safety program to be developed. The procurement of live material, timing during dormancy and availability had to be considered according to the dormancy of the live material, harvest and storage. There was a quality control on the live cutting delivery. As you can see here, there's the live cutting, and the pile here is approximately 25% of the one delivery was rejected because the cuttings were either dead or very diseased. So it's important to have that quality control, because if you're planting dead cuttings, it's going to impact obviously your outcome. Same with the nursery rooted stock. The source and the delivery are important to monitor and to ensure that native versus ornamental are used. And therefore the importance of the Latin name from the design versus what is delivered. Make sure we're getting the same species that we ordered. And also the inert material, such as log condition and dimension, rock quality, rock soil quality, and so forth. Other aspect of the implementation are the quality control, the design versus implementation. There's always some fill fitting adjustment to be discussed and approved with the contractor as required. In this case, we had minor changes were made during installation, and the design was adjusted for the core matting to go over the vertical log versus under them. There was the mixing, and then there was a mixing in preparation of soil amendment, the placement of the vertical log and lower horizontal log over the riprap rock, the pre-drilling at the junction of the log and placement of the 8mm rebar section, installation of some duckbill anchor, middle mesh, and live cutting placement, and addition of soil amendment in conjunction with planting. Then we have the placement of soil and double core matting, seeding under the matting with 40 kilogram per hectare, watering, then placement of the matting and the second horizontal log, second row of brush layers with the middle grid, and then this is the lower two section being completed. And here we can see the planting of the rooted stock and the rodent fence installed in between the rooted stock in the section between the rows. I would like now to talk about the importance of the maintenance program, which includes an irrigation schedule, weeding of invasive and exotic, plant replacement during each season due to mortality, structural repair if required, rodent fence, annual maintenance, report to the consultant monthly and city administrator on the work performed, and the removal of the temporary structure at the end of the maintenance period. I will now talk about the monitoring aspect of this project. This site was included in the riparian monitoring program between 2018 and 2022. The site assessment included botanical and structural aspects such as plant establishment and growth, structure integrity, and failure. The site was also monitored after completion in 2017 by the consultant, the city, and myself. In 2017, we had a good initial vegetation establishment and very good growth after one season. In 2018, there was minor tenting on the core matting in places as noticed. Some logs were off the ground or not sitting properly on the wooden post. Very good growth for the second season. But good survival overall on the vegetation, minor mortality on Prunus virginiana, the pincherry, and there was good sign of maintenance noted. So you can see here, this is the currant, golden currant and the Saskatoon berry getting established in between the rows, and as well as the grasses. 2020, the sprinkler head was noticed that they should have been installed higher because they were hitting the vegetation and we had poor coverage. Also, we found some dry rot at the end of the. In 2020, the beaver damaged the irrigation line in two locations at the bottom of the site. The rodent fence was also damaged in the spring and repair, allowing for 27 meters of long rodent damaged portion on the site to regrow extensively. You can see here the shoots after the damage repair and how they look like in September. Botanical monitoring 2020, the seeding was being shaded out and species selection of shrub based on moisture gradient and shade tolerance planted in between brush layers within live grading were doing really well. The use of soil amendment in conjunction with planting and quantity use seemed to have yielded a good result. And here we can see the berry on the red osier dogwood. So the lesson learned on this project were the design suitability for the site was satisfactory. The importance of considering the property of plant species, tolerance and shade to moisture. Toe riprap should have been vegetated to match the woody vegetation trim line. As you can see here, we could have easily had one layer of vegetated riprap, which would provide better habitat and toe protection. Specialized equipment could have been used to reduce the number of mature tree removed. The seeding application was too high at 40 kilogram per hectare, so 25 kilograms should have been used. Due to engineering concern, the slope gradient was flattened from the initial design to 1.5 to 1, and other application types such as brush layer in the class 1M riprap toe could have been used. In conclusion, the Riverdale site phase 2 downstream was the best site of the year for 2018 and 2020, and the highest rated site of the City of Calgary riparian monitoring program. Some of the highlighted feature in the design included the low level of soil compaction, brush layer as technique using deep planted live cuttings, high density of cutting per linear meter, providing large root mass to assist in bank stabilization and substantial top growth, shading invasive weed over the site, gradient of shade and moisture selected rooted species planted in between brush layers row, soil amendment used in conjunction with the planting of live cutting and rooted tree and shrubs, native graminoid seeded at the prescribed application rate and applied under the double core matting. Live grading provides large woody debris on site, which help maintain riverbank structural integrity, retain moisture, and enhance soil microorganism biodiversity. Rock toe to prevent scour and good quality plant material. Good implementation per design and maintenance was provided during the contract. Thank you for your attention.